We're back. Hopefully this one won't be quite as long as the last lesson, but there's a lot going on. But first, I did want to start off with a scientific fact. Did you know that when a pterodactyl goes to the bathroom, you can't hear them? Do you know why that is? It's because the P is silent. Ha ha! Thanks to Jenna for that joke. If you didn't get it, don't worry about it. We're going to move on. First thing we're going to talk about today is something called the zero product property. It's a pretty simple idea. It's just if you multiply two things together, which is what a product is, right? When you multiply two things together. If you multiply two things together and your product is zero, what does one of the factors or one of the multiples have to be? Well, in order to multiply zero, x would have to be zero, right? The only way to multiply and get zero is if one of your factors is zero. So we know that the x in this one would be zero. Likewise, if we do x times y equals 0, I don't know what either number is, but I do know that if they multiply to 0, either the x is 0, and 0 times whatever this is will give me 0, or if the x is not 0, the y would have to be 0, because then 0 times x would also be 0. Likewise, if we have two binomials, and we multiply them together, if we multiply them together and we get 0, we know that either this binomial becomes 0 or this binomial becomes 0. So essentially I know that either x plus 5 is equal to 0 or x minus 2 is equal to 0. So the way that I would solve this to find which x values I would need to plug in is I take this x plus 5 and I literally set it equal to 0. And then I solve it. Subtract 5, and if we subtract 5 from both sides, x equals negative 5. So if I were to plug negative 5 back into this binomial, negative 5 plus 5 is 0. And 0 times anything gives me 0. So negative 5 is one of my solutions because when I plug it in, it turns that factor to 0. Likewise, our second solution would be whatever turns the x minus 2 into 0. So I can do x minus 2 equals 0, add 2 on both sides, and x equals positive 2. So if I plug positive 2 in, 2 minus 2 is 0, and 0 times whatever this is will always equal 0. So again, when we're doing these, when we talk about the zero product property, it means if we multiply to 0, either the first factor is 0 or the other factor is 0. So again, this one here, my first factor is x. My second factor is x minus 7. And if they multiply to 0, I either know that this first factor is equal to 0, so x equals 0, or I know that my second factor is equal to 0. So x minus 7 equals 0, which means x would have to equal 7. So I know that either of those answers would be a solution to this equation. If I plug in 0, I get 0 times 0 minus 7. So 0 times that would be 0. But if I plug in 7, I would get 7 times 7 minus 7, which 7 minus 7 is 0. And 7 times 0 is 0. So you end up getting two possible solutions. So in conclusion, when we're talking about the zero product property, when you multiply to get 0, you're going to solve it by setting each of your two factors equal to 0. All right, if you're lost, let me clarify it for you. If we factor and we get x times x plus 4 is equal to 0, I know that when I multiply these together, I get 0. So either this first factor, x, equals 0, or I know my second factor, which is x plus 4, I know that that has to equal 0, and I solve it, and I get my second solution would be negative 4. So my two solutions for this problem are 0 and negative 4. Either one of them, if I plug them in for x, is going to give us something that multiplies to 0. Same thing here. If this times this equals 0, either this factor equals 0, So I do x plus 9 equals 0, or this factor equals 0. I know one of those two factors is going to become 0. So to find my solutions, I just solve this problem. Subtract 9, x equals negative 9. And then my second solution will be x equals 1. So again, if I plug in 1, 1 minus 1 is 0. 0 times that binomial will always be 0. Or if I plug in negative 9 plus 9 is 0, and 0 times that will be 0. If you've got a trickier looking one, it's still the same thing. I can set this factor equal to 0. So 2x minus 5 equals 0. Add 5 to both sides. 2x equals 5. Divide by 2. And x equals 5 halves, or I can put 2.5. And then to get my second solution, because quadratics, and we'll find out later these are actually quadratics as well. So if we multiply them with the box, we get a quadratic. But our second solution will be 3x plus 7 equals 0. And then we solve it. Minus 7. Divide by 3. And you get x equals, you can either leave it as negative 7/3, or what is that, negative 2.33 repeating. All right, so long story short, when we have two factors equal to 0, we set each factor equal to 0 and solve. That's called the zero product property. All right, we're going to come back to that idea in a minute. But first, I want to talk a little bit more about what solutions are, because we're going to start solving today. When we solve quadratics, we can call them the solutions. We say the solutions are 2 and negative 2. We can also call them the roots of the equation, which we'll talk more about later. We can also call them the zeros of the equation. And the reason we call them zeros is it's the numbers that when we plug it in makes our equation become 0. So they're called our zeros. And then also, if they're zeros, it's referring to where we cross the x-axis. And when you cross the x-axis, your y value at that point is 0. So it's zeros, which is also where your x-intercept would be on the graph. So again, if we say find the solutions, if we say find the roots of the quadratic, find the zeros of the quadratic, find the x-intercepts of the quadratic, they really pretty much mean the same thing. You're solving the problem and getting your answer. The big focus for the next week and a half is going to be solving quadratic equations. And we've actually taught you the first method already. We did it in our boot camp. The first method was the square root method. The downside of the square root method is it doesn't work for every problem. But the problems that it does work for, it's a pretty easy one to use. So for example, if there's no b value, like let's say we had x squared minus 9 equals 0. If there's no b value, this would be an easy one for the square root method, because you might remember that's where we get the x squared alone. So I could add 9, and then I have x squared equals 9, and then to undo the squared, we take the square root, and that was where we got not just 3, but we get plus or minus 3, right? So we had problems like that. Square root method is also great if you have a binomial squared. So if we have something like x plus 2 squared equals 49. Anytime you have the binomial squared, we can take the square root. That cancels out. We get square root of 49, which is 7, but we always put plus or minus. And then we get the x alone, so we're going to subtract that 2, which gives us x equals negative 2 plus or minus 7. And then hopefully you remember doing this on Khan Academy, where you did negative 2 plus 7 is positive 5. And then negative 2 minus 7 was negative 9. So you ended up getting two different solutions. This one would be positive 5 and negative 9. So method number 1 for solving, we've already done. We did it on the boot camp. You guys have done Khan Academy on it. We've practiced it. And you guys did pretty well with that. So now we're going to move on to number 2, though. for problems that we can't use the square root method, our next option that we're going to try is solve by factoring. Factoring, right? We've done a lot of factoring this week. We did our intro, we did the day 1, we did the day 2, we learned how to factor completely, where we do the GCF and the box, right? So we're going to use factoring to solve quadratic equations. Solving means we're now going to add in an equal sign, and we're going to be able to find what the values of x actually are. There are 3 steps when we solve by factoring. So the first one is going to be set one side equal to 0, which is basically putting it into standard form. We're going to set it equal to 0. Second step is we're going to factor the quadratic side. So the side that doesn't have the 0, we're going to factor it. And then the third step is we're going to set each factor equal to 0 and solve for x. Or, what we did on the last couple slides, this is also called using the zero product property. Or, my homies call it the OPP. Yeah, you know me, but anyway, all right, we'll pretend I didn't do that. Moving right along. So, we've got our 3 steps. The first step is we set it equal to 0. That is done. The second step is we're going to factor the side with the quadratic. So, I look for a GCF. No GCF, so I go straight to the box. First term, first box, last term, last box, add to the middle, multiply to 12x squared, and I figure out my 2 missing boxes are negative 6x and negative 2x. Factor out my top row, which is x, figure out what needs to go around the outside to get my box. And I end up with the factors of x minus 2 times x minus 6. So up to this point, you guys are experts at this. We've been practicing it. The only difference now is this is an equation. It didn't just say factor x squared minus 8x plus 12. It said to solve it. So now we need to figure out how are we going to actually find the solutions. So we take this equals 0 part, we bring that down, and now we have what looks like the problems we started with today, which are the ones we used the zero product property on. So that last step, the third step, was to take each factor and set each factor equal to 0. So I'm going to take this factor here. I'm going to write x minus 2 equals 0. I'm going to take my other factor, and I'm going to also set that one equal to 0. I'm going to solve each problem. I'm going to add 2 on both sides, which gives me x equals 2. And then I'm going to do the same thing here. I'm going to add 6 to both sides, which gives me x equals 6. And voila, we have got our 2 solutions, because quadratics usually have 2 solutions. Our solutions are positive 2 and positive 6. How could we check our answer on these? That's right, we're going to plug it in, right? Plug it in, plug it in. If you want to check your answer to make sure it's right, you would plug in 2. 2 squared is 4. Negative 8 times 2 is negative 16. And then we've got plus 12. And if I go left to right, 4 minus 16 is negative 12. Negative 12 plus 12 is 0. It worked. I could also double check 6. If I plug in 6, I get 6 squared is 36. Minus 8 times 6, which would be 48, plus 12. 36 minus 48 is negative 12. Plus 12 is 0. So both of these solutions, if you plug them in, they work. All right, moving right along. 3 steps. First step, make one side equal to 0. Okay, well that's a problem because that is not 0. That is 11x. So to set it equal to 0, I always want my x squared to be positive. So since this is positive, I'm going to leave it there. What I'm going to do is I'm going to subtract the 11x. When I subtract the 11x, that gives me 0 on this side. And then I'm going to put them in order in standard form. These are not like terms, so I can't combine them. I'm going to put my x squared first, and then I'm going to put my minus 11x next, and that's all I've got. So step 1, set it equal to 0. Step 2, factor the quadratic side. So you might notice there's no c value, and the flow chart we did yesterday said if there is no c value, we can always take out a GCF. So when I look at these two terms, my common factor is x, and then I figure out what's left over, which will be x, because x times x is x squared, and then x times negative 11 gives me the negative 11x. So we have now factored it. That was step 2. And then step 3 is set each factor equal to 0. So I'm going to take my first factor, which was x, and I'm going to set that equal to 0. No more work to do. It is done. And then I'm going to take my second factor, which was x minus 11, and I'm going to set that equal to 0. Add 11 to both sides. And my second solution is x equals 11. So I end up getting 2 solutions. When you're doing this on Elluminate, you'll probably get this kind of like set notation. It'll say 0, 11. That doesn't mean it's the ordered pair 0, 11. It just means that your solution set are the numbers 0 and 11. So it's showing that both of those are solutions. All right, some more practice. So step 1, set it equal to 0. Perfect, already done. Step 2, factor. I've got 3 terms. I'm going to look for a GCF because that'll make factoring easier. And I notice that I have a common factor of 3, which leaves me with x squared plus 6x plus 8. And then I'm going to try to factor what's left over using the box. And I'm going to do x squared, so first term first box, last term last box, add to the middle, multiply to 8x squared. That's going to give me 4x and 2x. Take out my common factor, multiply around the outside to get what's left over. And I can write down my factors of x plus 2 times x plus 4. And then I've got to remember to bring this 3 down. And I also have to remember to bring this equal 0 down, because we are going to continue to solve. The nice thing about solving is we need to solve for x. And you notice that this GCF didn't have an x on it. So it is one of the factors, but because there's no x there, it's going to be irrelevant to us finding our solutions. So I can actually ignore that GCF on this problem because it didn't have an x. If it had an x, I would need to use it. This factor does have an x though, it's x plus 2. So I'm going to set that equal to 0. This other factor also has an x plus 4. So I'll set that one equal to 0, and then we'll just solve. To get x alone, we subtract 2. And then to get x alone, we'll subtract 4. And our 2 solutions are x equals negative 2 and x equals negative 4. Just so you know, if we didn't take the 3 out right here, we could have still factored this using the box. We would have got binomials that look slightly different, but when we solved it right here, we still would have gotten negative 2 and negative 4. So math is pretty amazing. It's cool how these things work out. All right, on to the next one. What's wrong with this one? Why can't I factor it yet? That's right, we need it equal to 0. So I like that this x squared is positive, so I'm going to leave this stuff on the left. I'm going to add that 7 to turn the right side into 0. X squared plus 8x. The 7 didn't have a like term, so I'm just going to put it right there. It's my c value. So now we have our quadratic equal to 0. The second step was factor. So we're going to try to factor this. There's no GCF, so I go straight to the box. X squared, positive 7, adds to 8x, multiplies to 7x squared. The only way to multiply to 7 is, well, and add to a positive is to use a positive 7x and a positive 1x, which gives us x here, x there. To get 7x plus 7, and to get 1x we need plus 1. And I'll tell you what, as I do these problems, it's crazy how much you guys have learned in just 2 weeks, right? Like these are pretty tough problems, but you guys are persevering and you're able to do this. It's pretty cool. So great job. Keep up the good work. we get x plus 1 times x plus 7. But since we're solving, I need to make sure I put my equals 0. And then our last step, set each factor equal to 0 using the zero product property. So x plus 1 equals 0, x plus 7 equals 0. Subtract 1 on both sides, and our first solution is -1. Subtract 7 from both sides, and our next solution is -7. And again, if you're doing a test or quiz and you want to make sure your answer is correct, you can always plug these numbers back in, -1 or -7, and when you plug them in, it should give you a -7. It'll end up equaling, and you'll have a true equation. All right. Equal to 0, that's good. Factor this side, use the box. I'm going to go a little bit quicker now. We need to add to -5x, multiply to -24x, so that's going to be -8x and +3x. Factor the top row, figure out how we get the rest of the terms that are in the box. And we've got our factors of x plus 3 times x minus 8 equals 0. So that was step 2. We factored the quadratic. Step 3, we're going to set each factor equal to 0. So x plus 3 equals 0. X minus 8 equals 0. And we solve. We get x equals -3. And over here, x equals +8. This might be a little overwhelming, but hopefully the more you see it, the more comfortable you're going to get. This one, hopefully we recognize that it's not equal to 0, so we need to add 36 to both sides. Gives me 2x squared plus 18x plus 36 equals 0. Then we go to factor. I'm going to actually purposely forget to take out the GCF on this one, so you can see the disadvantage of not taking out the GCF, but also see the problem will still work. So the GCF is 2. If I take it out, my factoring is going to be small numbers, or smaller numbers. But if I don't take it out, I'm going to end up with some pretty big numbers. I've got 2x squared, 36. I need to add to 18x, and I need to multiply to 72x squared. So now I'm thinking, all right, I need to multiply to 72, add to 18. Well, there's a lot of things that multiply to 72. I can do 1 times 72, 2 times 36, 3 times 24, 4 times 18, 5 doesn't work. Ooh, but 6 times 12, that will work. So I can do 6x and 12x. Those multiply to 72x squared. They also add to 18x. So by not taking out the GCF, I had bigger terms here, which led to more options, more possibilities, which meant more guessing and checking before I could get these two terms. But once I do this, it's the same thing we've always done. Take out my GCF, figure out what goes there, figure out what goes there, figure out what goes here, which to get 12, that's going to be plus 12. And now I get 2x plus 12 times x plus 3 equals 0. And then I might go, oh man, I had a common factor. I could have taken a 2 out at the start. But if I don't notice that, I'm still going to get the answer right because I'm going to set this equal to 0. And when I set it equal to 0, I solve it. And I end up getting 2x equals -12 divided by 2. X equals -6. Had I factored it, I would have gotten x plus 6 right here, and it would have been a simpler equation. But I still got the right answer. And then same thing, I take my second factor, my x plus 3, set it equal to 0, subtract 3, x equals -3. So again, if you forget to take out the GCF, you'll still get the right answers, but we had to deal with numbers that were quite a bit larger, and it made the work just a little bit more difficult. But we still got the same correct answers. All right, let's see. Yeah, we'll do 2 more. Actually, we'll just do this one. I think you guys have seen a pretty good amount of solve by factoring. So again, the 3 steps. Step 1, set it equal to 0. That is not 0, so I need to undo that and move it back to the other side. That gives me 0, that's what I want. Not like terms, so I cannot combine them, but I put my x squared first, that's my a. Then I put my x second, that's my b. And then there is no c on this problem, which means it's an easier problem to factor because the only thing we can do is take out the GCF. GCF for 2x squared and 14x is 2x, which will leave us with x plus 7. So that was step 2, we factored the quadratic. And then step 3, we're going to set each factor equal to 0. So now I've got 2x equals 0. Divide by 2, x equals 0. And then I'm going to set my second factor, x plus 7, equal to 0. Subtract 7 on both sides, x equals negative 7. All right, I'm going to skip this problem for now. And I'm going to do one last problem, which is going to actually introduce us into what we are doing next week. Actually, you know what? You guys have enough going on. I'm going to leave you hanging. If you really want to try this, you can go ahead and try to solve it by factoring. And when you factor this, which I guess if we're solving, I need to get equal 0. If you factor this, send me an email with the factors, and I'll give you some extra credit. Okay? But hint, you can't factor it. All right, have a good one.